next we consider the low frequency response of the BJT circuit. Okay, for this course, for the low frequency and high frequency response, we will consider only common emitter configuration. Okay, so as mentioned in the previous video, at low frequency, the coupling capacitor and the bypass capacitor will affect the performance of the amplifier because it will affect the circuit impedance. So the coupling capacitor, for example, in this common emitter configuration circuit, we have coupling input CS, we have the coupling at the output CC, and then we have the bypass capacitor CE. So when we draw the equivalent circuit at low and equivalent circuit at low frequency response, so what will happen is the CS, CE, and CC appear in the equivalent circuit because the capacitor is no longer considered as short circuit. Okay, so and then for this low frequency analysis, one of the main objective for this analysis is to determine the low cutoff frequency. So how we can determine the low cutoff frequency is by consider the time constant. So the time constant of the RC circuit. So I think you have learned the RC circuit in your circuit analysis. So the time constant is tau equal to RC, and then this is equal to 2 pi F. So FC. So this is F is the cutoff frequency. So the FC is equal to this is let me correct this one. This is not 2 pi FC. So this is actually a 1 over 2 pi FC. Okay, let me correct this one. So this is 1 over 2 pi FC. So and then you have the FC is equal to 1 over 2 pi RC. So this is how we can estimate, how we can predict the cutoff frequency at the low and high frequency region. So we have here three capacitor. So the value of capacitor here is from these three CS, CC, and CE capacitors, and then the R value here is will be the impedance of this circuit. So the cutoff frequency. So how we do the analysis is we consider the calculation for one capacitor each. So for example, so actually we have three capacitor. We have the input coupling, and we have the output coupling, and we have the bypass. So the first case, or the first step, is we only consider the case where only input capacitor appear. So only input capacitor CS. So in this case, if we use this cutoff frequency F equal to 1 over 2 pi RC. So in this case, the capacitor value is only CS. But the R value is the total impedance or resistance of the amplifier. So this is RS plus the input impedance. So this is the impedance seen from this CS point. So this is input impedance. So we will have we can have the cutoff frequency due to the CS only. Okay. For this common emitter configuration, the input impedance is defined by this R1 parallel with R2 parallel with R pi. Okay. Next, we consider the case where only the output coupling appear in the circuit. So the input coupling as well as the bypass coupling is considered as the short circuit. So in this case, the value of the capacitor is only CC because this is CC, but the value of total resistance is RL, because it's at the output part. This is RL plus Z out. So Z out is equal to RC. So we have the another cutoff frequency. Okay. So and then the last one is when we consider only the bypass capacitor here. So here you can see there is no input coupling, no output coupling, only bypass capacitor CC, CE. So for the FLE, the value of the capacitor is CE. Okay, how about the value of total resistor? Total resistance is the impedance or resistance seen from this point. So seen from this CE point. So when you see from this point, you will see RE, and then parallel with what we call it as a ZE. So this the REQ is equal to RE parallel with ZE. Okay. So and then this detail of calculation of ZE is actually being we have discussed this in previous week. So please refer to the previous week slide. So the value of ZE will depend on whether you have the RS or whether you have the R1, R2, or if you have the only RB. So this is will slightly different. So in this case, the ZE is equal to R pi plus this is RTH. So RTH is actually the RS parallel with RBB. So again, the ZE, the calculation of ZE, I do not recommend you to use this to memorize the equation to calculate the ZE. So because the ZE is different, depend on the circuit. Whether the circuit have the RS or not. Okay, so after we done the analysis, so we'll have three cutoff frequency value. So we have FL, the input. Let's say I put is the input coupling FLI, and we have the FL for the output, and then we also have the FL due to the bypass capacitor. So we have three cutoff value, low cutoff frequency value due to the specific capacitor. Okay, so this is coupling, input, this is coupling, output, and then this is a coupling, this is a bypass, bypass. Okay, so in the board plot or in the actual amplifier, that we will only have one value of low cutoff frequency. So to do the estimation of the low cutoff frequency, so what we'll do is we choose between these three calculated cutoff frequency, we will choose the highest. So we'll choose the highest value. So we choose the highest value become the FL, the actual low cutoff frequency. So why we choose the highest? Because the highest will become the highest frequency value is the value that is the closest to the midband. If you consider the plot of the book, plot. So we have the midband is the frequency range at the moderate value. So from the midband towards this is frequency from the midband, okay, towards the low frequency. So it will meet the highest frequency. So let's say we have here, this is FLB, this is FLI, this is FLO. So the one that is closest to the midband is FLB. So it will first affect the gain of the BJT. So it will start to decrease or start to start to decrease or start to reduce the gain of the BJT. Okay. So this is the actual cut-off frequency. So let's see the example. So let's say this is the common emitter with the bypass capacitor. So we have here the CS, CC, and CE is given, and then GM is also given, is 50 millisiemens, with the VA is equal to infinity. So this case is R0 is infinity. So the R0 will not appear in the equivalent circuit. Okay, so the equivalent circuit at the low cutoff frequency, low frequency region is will become like this. So we have here the CS, CC, and CE appear in the equivalent circuit. Okay, so the next thing is, if you want to calculate the low cutoff frequency, you need to consider the cutoff frequency due to the CS, and then you have the cutoff frequency due to the CC. The third one is cutoff frequency due to the CE. Okay, this is the calculation for the cutoff frequency due to the CS. So when we consider only CS, we will bypass the CE, so the RE will not appear, and then this CC will replace with the short circuit. So the calculation is F equal to 1 over 2 pi RC. The C is equal to CS, which is 4 microfarad. For the resistance, the total resistance is RS plus ZI. So ZI is R1 parallel with R2 parallel with R pi. Okay, remember that since for this case, we consider the CE to behave as the short circuit, so there is no RE. So from this calculation, the ZI is equal to 4,411 ohm, and then the calculated cutoff frequency due to the CS is equal to 4.35 Hz. Okay, so next we consider only the output at the output port. At the output port, the total resistance is Zout plus RL, and then the capacitor is only CC, so we'll have 2 Hz. And then the last one is when we consider only the bypass capacitor. So at the bypass capacitor, the calculation for cutoff frequency, the value for CE, capacitor we use the CE value, and then for the equivalent circuit, after the equivalent resistor, the total resistor in the cutoff frequency equation, the REQ, is defined by the RE parallel with ZE. So here the ZE, how we can calculate the ZE? The ZE is seen from the emitter port. So the ZE, we will see the RE, and then we will see the RS parallel with RB. So R pi plus RS parallel with RB over beta plus 1. Okay. So again, the explanation, I will not go into the detail on the explanation for the ZE calculation. You need to do some revision on the previous weeks, how we calculate the ZE. Okay, when we do the calculation, we will get the low cutoff frequency as 99.02 Hz. So now we have 3 cutoff value. So we have 3 low cutoff value, cutoff frequency. So the first, the input is 7.35, the output coupling 2 Hz, and then the bypass is 99.02 Hz. So which one will be estimated as the actual low cutoff frequency is the one with the highest value, which is a FLE. So the low cutoff frequency is 99.02.